So an infinite series is similar to an infinite sequence, except we are adding up all of the terms. So in an infinite sequence, the sequence converged if the terms approached a limit. So we're looking at the behavior of the terms as n approaches infinity. In an infinite series, we want to find out if we add up an infinite number of terms, will they add up to a finite sum? So an infinite series converges if it adds up to a finite sum, and diverges if it doesn't converge to a finite sum. It just adds up to infinity. So we can test this using partial sums, and the nth partial sum of a series is just the sum of the first n terms. For example, if we had this series, then the first partial sum would be just the first term, 1, and then the second partial sum would be the first two terms added up, or 3 halves, and the third partial sum would be the first 3 terms, which would be 11/6. So we can make a sequence out of these partial sums. So the first partial sum, the second, and the third, and so on, until n equals infinity. So we can look at the behavior of the sequence of partial sums as n approaches infinity. And if the sequence of partial sums converges to a limit, then the series must add up to some finite value. So the series will converge to a sum which is the same thing as the limit of the sequence of partial sums. So one type of special series is a geometric series, which is just like a geometric sequence. We start with some number a, and then each time we multiply by a ratio. And if the ratio is less than 1, it converges, and otherwise it will diverge. And so if a geometric series converges, then the sum will always be a over 1 minus r. If we have this geometric series, the first term is going to be 2, that's a, and then the ratio is 1/4. So since the ratio is less than 1, we know that this geometric series will converge to a sum. And that sum will be a over 1 minus r, or 2 over 1 minus 1/4, which is just 2 over 3/4, or 8 over 3. So 8 over 3 is the sum of this geometric series. If we keep adding up a bunch of terms, in infinitely many terms, then the sum will be 8 over 3. So one type of special series is called a telescoping series, which is when a lot of the terms cancel out. So to see how this works, first we need to use partial fraction decomposition on the general term of this series. So we can decompose it into 1 over k minus 1 over k plus 1. Now, if we write out the sum, the nth partial sum of this series using this form, then it becomes more clear how the terms cancel out. As you can see, we have a negative 1/2 and positive 1/2, negative 1/3 and positive 1/3, and so on. So when all these terms are added up, everything in the middle cancels out, and all we have is 1 minus 1 over n plus 1. And then remember, we can take the limit of the sequence of partial sums as n approaches infinity to find the sum of the original series. So the limit as n approaches infinity of the nth partial sum is 1. So this telescoping series converges to 1. And another special series is the harmonic series, which is 1 over k, starting at k equals 1. And so this is a diverging series.